So welcome for today's lesson. So today's lesson we are having interesting topic, which is our first topic for today's lesson, which is accuracy and precision. That is our today's lesson. So accuracy and precision. So what is accuracy and precision? So you are able to see that. So what is accuracy and precision? So accuracy and precision deals with the measurement. So let's give an example. You are measuring something, or they have given you like something in the bigger ear. They have asked you to measure which is something which are in ear. Then they speculate that this measurement or this measurement which you get should be 20 20 like mils, like example. Yes, or 20 moles. I can give just an example. They have given you to measure like this 20 moles. Now you they have given you three trials to try. So the first trial you measured 29. The second trial you measured 28.7. The third trial you measured 28. Now there is another one, another person. This is person one. I say the measurement A. That's person one. This is person B. Another one, start measuring. You measure the same one. We measure 20.1, or you measure 20. Then they tell you. You measure another which is 9. I'll give 17.5. So they ask you which measurement is accurate and which measurement is precision. What is the correct answer here? Men will say precision, it is this one. Accuracy is this one. Now, explain the reason why you have picked this one to be accurate. So accuracy, the definitions comes in. Accuracy, it is how close are the measurement to what? To true value. So the true value is 20 meter, 20 moles. So you have measured 20.1 moles, 20 moles, 17.5 moles. So you are close here. You are what? Accurate. Yes. While the other measurement here, when you look at this measurement here, it is precise, because even if it is not accurate, the values we can see this is 29. He measured 29. Second, he measured 28.7. The third one he measured 28. So this precision, this means that how close are the measurement to each other. So to each other the measurement, even if they are not correct, sometimes they will be correct, sometimes they will not be correct. So the definition takeaway, you need to say accuracy. So accuracy, how close are the measurement to each other. So that is accuracy. While precision, the takeaway point is how close are the measurement to each other. So to each other. That is what we are calling what? Precision. How close are the measurements to each other? Accuracy due to the true what? How close are the measurements to so how close are the measurements to true value? So accuracy deals with the true value. That is what we call accuracy. So how close are the measurements to the true value? That is what we call what? accuracy, so to the true value. That is the thing which we need to know on accuracy and precision. Let's go to our question which we have prepared for today's lesson. So here is a question which I have prepared for today's lesson. So when you look at this, it is an experiment. In a chemistry lab, three students, Alice, Brian, Cindy, were asked to measure the concentration of the solution. The actual concentration of solution is, so the true value is what? Mole per decimeter cubed. This is 5.0 decimeter cubed. Each student took four measurements recorded as follows. So Alice recorded this: 5.0, 5.1, 4.9, 5.0. Brian recorded this: 4.0, 6.0, 5.5, 5.5. Cindy recorded this: 4.5, 4.6, 4.5, and 4.6. Now, the question which is there is, which student measurement are the most precise? So, which student are most precise? So, when you look at this, precise means how closer are the measurements to each other. So, when you look at, let's start with this. R is 5.0, 5.1, 5.9, 5.0. So these measurements, they are close to each other. So Aris, you put a mark to Aris. Then you go to Brand. We have written the data which they have given us in the table. We go to Brand. Brand is 4.6, 6.0, 5.5, 5.5 here. So even though Brand is closer to the answer, is not what? Even though it's not even closer to answer, if is not even precise, because when you look at 4.0 go to 6.0, they are not precise. Yes, it's not precise. When you go to Cindy, 4.5, 4.6 is also precise. 4.5 and 4.6 is also precise. Yes. Now the question will state as which. So this is precise. Yes, even here it's precise. Yes. Now the question which student measurement are the most precise? So when you look at here, which measurement are the most precise? What is the answer here? So which student? So here we have two categories, this one and this one. So here, when you look at 4.5 and 4.6, so the most precise here, it is, when you look at here, there are two repeated. When you look at 4.5, even here 4.5. Then 4.6, even here 4.6. So they are very much closer. When you look at 5.5, 5.0 now, here it's what? 5.0. So they are closer, even though they are closer. 5.1, 4 point what? 4.9. Even though they are closer. Now, here we have two common. 4.6, 4.6, 4.5, 4.5. So the correct answer, it is what? Cindy. That is the correct answer. Now, we go to question 2. Which student measurement are the most accurate? So accuracy deals with what? The true value, which is what? 5.0 more. So when you look at here, it's 5.0, right? That is, which one is closer to 5.0? So when you look at here 5.0, 5.1, 4.9, 5.0. So here the first Aris is closer here. Aris is closer compared to others. So Aris, which student measure are most accurate, which is Aris. Yes, that is Aris. Then you go to question 3. Which student measurement are neither accurate nor precise? So which student measurement are neither accurate nor precise? Which one of these? So when you look at here, it's not closer to each other, or it's not closer to the true value. So brand 4.0 is not closer to the true value. 6.0 is not close to 5.1, is not close to the true value. Even 5.5 is not closer to 1. So the answer here should be what? Brand. So the last one, which students' measurement are both accurate and precision? Which one of them? When you look at which one is both accurate and precise, so 4.0, 6.0, 5.0 is not even closer, even not accurate. Cindy 4.5, 4.6, 4.5, even though Cindy is precise but not accurate. Accurate is 5.0. When you look at Cindy 4.5, 4.6, 4.5, 4.6. So the final answer here should be what? Alice, because Alice is closer to each other and closer to what? To the true value. So the answer, the next one, it is what? Alice. Yes. That is the only thing which we need to know. Yes. Now, so you can try to practice many questions as possible. So that is the only thing which you need to know on accurate and precise. So it is simple and easy. So let's move on to another thing which we need to know, which is relative atomic mass. So relative atomic mass. That is the other thing which we need to know. Relative atomic mass, which is RMA. So what is this relative atomic mass? So this is the average mass of an element compared to carbon 12. Yes, so this is the average mass of an element or of an isotope, because when we start dealing with a relative atomic mass, we'll be just dealing with different isotopes. That is what we call relative atomic mass. So relative atomic mass is the average mass of an element compared to carbon 12. That's all. That is relative atomic mass. And the formula which we need to know, it is mass times so which is, this is percentage abundance, then plus m2 mass 2 times x2. So that is what you need to know on relative atomic mass over 100 over 100. So that is the formula we need to know. So where m is equal to what? M is mass 1, x, which is mass of an isotope, then x is which is percentage abundance. So percentage abundance. That is the only thing which we need to know. So this m means mass 1, x means percentage abundance. And the other thing which we need to know is, when you add this abundance, it is in form of percentage. So when you add this abundance, x1 and x2, they need to give you what? 100%. That's why sometimes they will give you questions to find relative atomic mass, or they will give you relative atomic mass, you need to find mass 1, or they will give you different questions, which will help you. You just need to know this formula. That's all. If they'll give you that the first abundance, it is, they say it is 75. Here they'll give you 75. What is this another percentage abundance? So you will just do 100 minus 75, which will give you what? 25. That is the percentage abundance which you use for another one. Yes. So percentage abundance for this and for this should give you what? 100. That's all. That's the only thing which you need to know. Now let's go to practice question. which will enhance your understanding. So this is our question. Yes. So now this question was given. They give us three masses. So when you look at these three masses, they have given you three masses like this. So mass 1 is 24.0, and when you look at here, they have given you what? Masses 24.0, 25.0, 6.0, 6.5, and 20.0. So I just categorized here. In the question, they will give you this is the abundance of this, oxygen as the abundance of this, as abundance of this. Now find relative atomic mass or average mass they will give you. So you just need to do what? You just correct data like what I did here. You just write mass 1 24, mass 2 25, mass 3 26, x1 the abundance 1 64, abundance 2 20, and x abundance 3 15.5. So all those should give you, we just say all those should give you 100%, right? Sometimes they'll give you these two, they'll give you the abundance for this and for this. Then they haven't give you the abundance for this. What should you do? You just insert, you just subtract the abundance, because if you add, try to add 64.2 plus those abundance which is 20.3 plus 15.5. So when you add this, should give you what? 100%. They have proved this. Yes. So always it should give you 100%. So when you calculate the relative atomic mass here, it will give you like this. Then you find the final answer. We find is this. So relative atomic mass, it's simple and easy. So you just need to practice as many questions as possible. And another question which they have asked you, identify this atom, identify this element. So you go just to periodic table. So 24.54, that is our relative atomic mass. So you go to the periodic table to identify that. Yes. So you identify magnesium is closer to that element, so that it will give you 24.31. So that is the only thing which you need to know on relative atomic mass. Just the formula. Yes, the formula, then you collect data, then you can answer different questions on relative atomic mass. Yes. So let's go to empirical formula. So empirical formula, empirical formula. So empirical formula, what is empirical formula first thing before you proceed? So what is empirical formula? So empirical formula, it shows the simplest whole number of an atom of an element. So empirical formula, it just shows how you can write that element in a simple way, because they'll give you questions where they just say a compound as this element, the compound as this, the mass of this, or the grams for this is this element. Find the so they'll ask you find the empirical formula. Yes, let's give an example of a compound which contains magnesium, so that it will help. I'll explain in the form of question so that you can understand. A compound contains magnesium which is 9.2 grams, right? Then, and also oxygen, we say oxygen is 7.6 grams. Then they will ask you, find the empirical formula. What should you do? So don't worry, because these questions, they are simple and easy. Yes. So what should you do if you have given you that question? So the first thing there, I've explained there in the document. Try to use Thrive Achievers Exam Study Help. I've explained. I said the first thing, find the moles. Find the moles. Second thing, divide the lowest answer. So when you find the moles, divide the lowest answer or the moles. That's what I will say here, so that it will help you. So the first thing, find the moles. Second, divide the lowest answer or the moles. Third, then after you divide the lowest answer, then there is a principle we use to find when you want to round off, because it should be in between. It should not be in between 2.8. So when you divide the lowest answer, then you found the answer. Your answer is in between 2 and 8. You should not round off. You just need to find the number which will give you out of range. Out of range there. Yes. We don't round off. If the answer give you like 0.2, in between 0.2 and 0.8, you should not what? You should not round off. When you divide the lowest answer, you should not round off the answer which will give you in 0.8 and 0.2. That's the only thing which you need to know on empirical formula. Now let's try to answer the question, the same question there, which is said magnesium is what? So the question will say magnesium is equal to what? 9.2. Then oxygen is 7.6 grams. So the first thing, find the moles. So we know the moles is equal to what? Mass over Mr. That is the formula for moles. So moles is equal to what? Mass over Mr. That is the formula for moles. Now what is the mass? So when you look at each element, you can find the moles. Each of the elements, you can find the moles. So 9.2, right? 9.2. So we start with magnesium. So you start with magnesium here. So this is magnesium this side. Try to help you. So 9.2. That is the grams which they have given you in the question here. So 9.2 grams. Over, we want to find the Mr. for magnesium. When you go in the periodic table, it will give you a 24.31. Then you go to oxygen. So this side should be oxygen. So oxygen also, the question they give is 7.6. So the Mr. for oxygen is what? Which is 16. Now the answer which will give you is what? 0. When you divide here, it will give you 0.378. When you divide here, it will give you 0.475. Then the second step, I said you divide the lowest moles. So here, which is the lowest mole? So the lowest mole here, it is 0.378. Even here, the lowest mole is what? 0.378. So when you divide here, it will give you what? So when you divide here, it will give you what? So here, it will give you 1. Then this side, let's choose an, okay. So it will give you 1 because it's the same thing here. It's 1 there. Here to, when you divide, use the calculator to divide, it will give you 1.26. So after dividing here, I said there is a principle which we use. I explained this. So the first thing, find the moles. The second thing, divide the lowest, which is the answer which you will find here, which is 0.378. Then we don't round off. Here it's 1. We don't round off that the empirical. We assume that the empirical formula Mg, then we replace here, and oxygen we replace here. So we want to write the formula which will represent that element. That is what it means, empirical formula. So here we don't assume that Mg it is 1. Oxygen is 1 point. We round off, we say 1, we say 1, oxygen also is 1. That is totally wrong. Why? Because I explained this. I said we don't round off. I'll repeat. We don't round off, which is what? Which is in between of 0 point. Let me write here. We don't round off in between 0.2 and 0.8. Here we don't round off because when you look at here, it's 1.26. So 1.26 is in between 0.2 and 0.8. So it is in between. So the number which is in between, we don't round off. So we find the common 1 and 126, which will give us out of the range. Now, there is what we need to do. If it is the key there, if it give you the answer, if it give you 1.5, if it give you 1.5, you multiply by 2. That is the key. If it gives you 0.3, if it's given number which give you 0 point something or 3, you multiply by what? 3. If it give you 0.25, closer to 0.25, you multiply by what? You multiply by 4. Yes. So similarly here, it gives us 1.26. It's closer to 1.25. So 25 we multiply by 4. 0.5 we multiply by what? By 2. Yes. 0.3 we multiply. Even 0.6 we multiply by what? By 3. So here we multiply by 4. Yes, because it's equals to 0.25. Even here we multiply by 4. So the answer which will give you here, it will give you this side magnesium, it will give you 5, here it will give you 4. So the answer, the empirical formula, which is magnesium 4, oxygen 5. Because they make mistakes here, because they think that they will just multiply one, they just round off, they say 1 magnesium 1, oxygen 1. Then you are totally correct. That's why men got this empirical formula question wrong. So you try to practice different examination questions. Yes. Now let's move on. Molecular formula. So molecular formula, I'll just explain molecular formula so that you can, when you meet those questions on molecular formula, because they are also the key. Molecular formula. So molecular formula, what are the things which you need to know on molecular formula? Yes. So molecular formula is simple also. The reason is why. Why? What is the reason? First thing, we need to define what is molecular formula. So molecular formula is just a way showing the exact number of each type of an atom in the molecule of a compound. So it's just another way of showing the exact. So here molecular formula deals with the exact number. Yes. So exact number of an atom. That is what we call it, molecular formula. And molecular formula, you have calculated already the empirical formula, right? So molecular formula is deals with any, that's a number. Then here it is empirical empirical formula. So here it's empirical formula. So you multiply by empirical formula. So if n is equal to the empirical formula, if you say you found it is, I'll say, let's give an example, the one which we have from calculating, say magnesium 4, then oxygen 5, like this. So that is empirical. We multiply by empirical formula, then times the n. Now, how do we calculate that n? So if the n is here, it's 2. you calculate the 2n. So then you multiply by mg. So mg there, which is 4, then oxygen also 5. So if you calculate that 2, n to be 2, so we multiply 2 times mg, so it will give you mg what? 8, then oxygen what? 10. That is what we call what? The empirical formula. So that is the empirical formula. If you calculated n to be 2. Now the question is, how do we calculate n? How? N is simple because the formula for n is equal to what? Molar mass over empirical mass. That is the formula for n. Where do we get molar mass? So molar mass usually they will give you in the question. They will find in the question. So when you start answering the molecular formula, just go to the question. You find the molar mass. If it's 30, they will give you in the question is 30. Now empirical formula, you just need to calculate, because you calculate the formula like say mg for oxygen 5. How do you calculate the empirical mass? So you go on the periodic table, you start finding what is mg. Yes. So when you go on the periodic table, you find the mg is 24. 24 times what? 24 times 4. Oxygen is 16 times 5. So when you will multiply this, then it gives you the answer here. The answer here, if it gives you the answer here, yes. So when you add this, it gives you the answer. Then that is what you call the empirical mass, which you have calculated already the formula. Yes. So you just need to calculate the molar mass or the molecular mass for this, which is we call empirical mass, where the molar mass they will give you in the question. That is what you calculate the empirical formula. I will repeat also. The molar mass they will give you in the question. Empirical mass, you just need to calculate like what I did here, using the formula which you have calculated. If you have the empirical formula is mg for oxygen 5, then you find the mass of this. You have already learned how you can calculate the mass. So 24 times 4, 16 times 5. Then you have calculated the mass. Then you just add. You add the mass. So when you add the mass, that is the mass we will put in. Then when you go back to the question, you go back to the formula for calculating the molecular mass. So molecular mass, which is the empirical formula, which is mg for oxygen 5. That is the empirical. Or then we multiply n times 4, n times 5. That is what we calculate the molecular formula. So it is simple and easy. Yes.